Hello everybody, welcome into another lesson. Today we are going to talk about multiplying and dividing powers and exponents. So what we have here first is we have a number to the m power and a number to the n power. So this number a is any arbitrary number or variable. It's to one power multiplied by that same number or variable to another power. Whenever you have a number or variable that's the same, and you multiply it by that same number or variable to another power, you simply just take the two powers, you add them together. So for example, let's say I gave you 3 squared times 3 squared, right? What you would have to do is you're going to take that base 3, you're going to add your 2 and 2 together. So you'd have 3 to the 2 plus 2, which we know is equal to 3 to the 4th. So you would get 3 to the 4th power, because you got to add your powers together. Alright, well I got another example here. So the key is they have to be the same number to different powers. Okay, we have 6 times 6 to the 7th. So we got 6 times 6 to the 7th. What you're going to do, I would rewrite that 6 that's by itself as 6 to the 1st power, because that's what it is, a 6 to the 1st power. So you have 6 to the 1st times 6 to the 7th. Well, since we have the same power, and it's got to be the same power, otherwise, it's got to be the same base, otherwise it won't work. You have to have the same number, the same base. It won't work if it's different numbers. If it's the same, you're going to take that base 6, you're going to add the two powers together. So you'll have 6 to the 1 plus 7. Which, as we know, 1 plus 7 is 8, so your answer to this would be 6 to the 8th power. That's exactly what you would get, 6 to the 8th. Alright, let's see. We have 9 to the 4th times 9 to the 5th. Well, we've established they're both the same base. Both of them have base 9. So now, since we're multiplying these two expressions, 9 to the 4th times 9 to the 5th, you're going to have the base 9 still. You'll just take the 4th power, so you'll have 4 plus 5. You'll have 9 to the 4 plus 5 power, which 4 plus 5 is 9, so your answer would be 9 to the 9th power. That's the answer you get, 9 to the 9th power. Alright. Let's see, we have 10 to the 4th times 10 to the 3rd. So 10 to the 4th times 10 to the 3rd. Since they're the same base, we keep the base. Since we're multiplying, you're just going to add the two powers. You'll add 4 plus 3, which would have to mean that would be 10 to the 7th power. So the answer to this one is going to be 10 to the 7th power. Alright, we have a variable. We have d to the 4th times d to the 6th. So you'll have d to the 4th times d to the 6th. Well, the base is the same for both, so you'll keep your base d. Then you'll add the two powers together, so you'll have 4 plus 6 power, which we know 4 plus 6 is 10. So the answer to this would be d to the 10th power. That's the answer you get, is d to the 10th power. Alright, we have n to the 8th power times n. So, again, we have the same base. We're multiplying the same bases. So, you're going to keep your base n, I would rewrite this first as n to the 8th times n to the 1st, because just n is n to the 1st. Now you'll keep your base n, and the powers you'll add together. So you'll add the 8 and the 1 together. Well, 8 plus 1, last time I checked, was 9. So the answer you would get is n to the 9th power. Alright. We have t to the 2nd power times t to the 4th power. So they got the same base, we're multiplying the same base, so you'll keep your base of t. Now you'll add your powers of 2 and 4 together. 2 plus 4, that's 6. So your answer is going to be t to the 6th power. That's the answer you get, t to the 6th power. Alright. We have a to the 6th times a to the 6th. So what you're going to do, of course, keep your base, but you're going to add up your exponents, 6 and 6, so you'll have 6 plus 6. Well, 6 plus 6 is 12, so the answer you would get is a to the 12th power. That's what it would be, a to the 12th power. Alright, now how about this? 2y times 9y to the 4th. All of a sudden we have coefficients now on each of these monomials. We have 2y times 9y to the 4th. Well, first thing you're going to do, take your 2 times 9, that's 18. 2 times 9 is 18. Well, that y by itself, that's going to be like y to the 1st. You have the same base for your... You have the same base of y, so you keep your base of y. You have y to the 1st plus 4. Y to the 1 plus 4 is what you'll have. Because you did 2 times 9, that's 18. Then you have the same base y. So you'll add the 1st power plus 4th power. That's going to give you 18 times y to the 1 plus 4, which is the 5th. So the answer we're looking for here is 18y to the 5th power. Alright, we have 5r to the 3rd power times 4r to the 4th power. So we've been given 5r to the 3rd power times 4r to the 4th power. Well, of course, your coefficients you'll multiply. 5 times 4 is 20. You'll get 20 for that. You have the same base r, so you keep your base r, and all you're going to do now is add your exponents together since you're multiplying. You'll add the 3 and the 4 together for your exponents, which would just give you 20 times r, then 3 plus 4 is 7. So the answer you would get is 20r to the 7th power. That's the answer you would get. So you'll have next 10x times 4x to the 7th power. So you've been given 10x times 4x to the 7th power. Well, what you're going to do is you're going to, of course, multiply your coefficients. 10 times 4 is 40. You'll have 40 for your coefficient. You got the same base of x, so you'll keep x as your base. Well, that 10x, that x there is to the 1st power, so you're going to add up the powers of 1 plus 7. Add up 1 plus 7 for your powers. So your answer is you'll get 40 times x, 1 plus 7, that's to the 8th power. So the answer we're looking for is 40x to the 8th power. So again, when you're multiplying either a variable or a constant, which is a regular number, they have to be the same regular number or variable for both when you're multiplying. Then you simply add the powers together. That's all you got to do. All right. I think we've seen enough about multiplying. Now, let's say you're given a to the m power divided by a to the n power. Whenever you divide something that has the same base, whether it's a number or variable, they have to be the same number or variable like you would multiplication. But when you divide powers, you subtract them. So that's going to equal that base to the m minus n power. So you would actually subtract the bases of that, the exponents of that point. So for example, we have 5 to the 5th power divided by 5 to the 2nd power. So we got 5 to the 5th power divided by 5 to the 2nd power. Well, the base is the same. You're going to keep your base, but what you're going to do is subtract the power that's in the denominator from the power that's in the numerator. So you'll have 5 to the 5 minus 2, which we know 5 minus 2 is 3. So the answer you would get is 5 to the 3rd power when you do the division. You would get 5 to the 3rd power. All right. Next you have 8 to the 4th over 8 to the 3rd. Well, all we have to do here, we know the base of 8 is the same. Then you take the power in the numerator minus the power in the denominator. So you have 8 to the 4 minus 3, which would equal 8 to the 1st power, or just simply 8. You would just simply get 8 for that. This is a lot nicer, too, than writing out the prime factorization. We could have done the prime factorization method and arrived at it, but it would have took us a little bit longer. It's nice to know these power tricks, because then you can save yourself some time. Alright. So we have negative 2 to the 6th divided by negative 2 to the 5th. Well, we can clearly see starting out that the base is the same. That's negative 2. Now you would have to raise that, you'd have to raise that to the 6 minus 5 power. So you'd have to the 6 minus 5 power since it's divided by, which is going to give you negative 2 to the 1st power, or just simply negative 2. Well, I don't know why I had the parentheses like a dork there, but it would give you negative 2. Because you're taking the base. Of course, the negative 2 to the 6th is your numerator. The negative 2 to the 5th will be your denominator. So you're subtracting the power. You're doing the power in the numerator minus the power in the denominator. You arrive at 6 to the 6 minus 5 power, which is to the 1st power. Therefore, it's just negative 2. Alright, so we have 10 to the 10th power divided by 10 to the 2nd power. So we got 10 to the 10th power divided by 10 to the 2nd power. Well, we know the base is the same. We'll keep that base 10. Now you would take that to the 10 minus 2 power, because the 10 to the 10 is your numerator, that 10 to the 2 is your denominator. So you would do the numerator power minus the denominator power. So you'd have 10 to the 10 minus 2, which would leave the power of 10. 10 minus 2 is 8. So the answer we'd be looking for here is 10 to the 8th power. Alright, we have b to the 6th divided by b... Why am I doing 6? Dang it. Divided by b to the 3rd power. So we have b to the 6th divided by b to the 3rd. Well, of course, we're going to keep the same base. Now we have b to the 6th divided by b to the 3rd. So since it's divided by, you're going to subtract powers. That would be b to the 6th minus b to the 3rd power, which would mean that's b to the 3rd power, since 6 minus 3 is 3. So the answer we're looking for is b to the 3rd power. So really, this isn't too terribly bad. I got 2 more. We have a to the 8 over a to the 8. Well, right away we see we could just factor those both out and get 1, but I want to show it to you with a new method here. You have the same base a. In the numerator you have the 8th power, denominator you have the 8th power, so that'd be numerator power minus denominator power is what that base is raised to. So it'd be a to the 8 minus 8 power. Well, 8 minus 8 is 0. A to the 0 power. Assuming a isn't 0, in this case we're going to assume it's not, you would just get 1. Because a to anything to the 0 power, of course except for 0, is 1. So that would be the answer you get for that. And I got a last example here. We have m to the 20th over m to the 8th. So we have m to the 20th over m to the 8th power. Well, we see the base here, of course, is m. It's the same in both the numerator and the denominator. Now what you're going to do is take that m, raise it to the power of 20, the power in the numerator, minus 8, the power in the denominator. So you'll have m to the 20 minus 8, which would equal m to the 12th. So the answer we're looking for to this one here is m to the 12th. And so yes, when you divide two monomials or numbers that are to the same, they're the same base, from one power to another, when you divide, you subtract the second power from the first power, or you do the power that's in the numerator minus the power in the denominator. Same thing. So that's really all there is to the subtraction side. And we already covered the multiplication. So the next lesson is going to be negative exponents. Yes, there actually is such a thing. We will talk about negative exponents and what those mean. So I hope everybody has a good day. Take care.